Hey everyone, and welcome to this explainer. Today we're jumping right into what I can honestly say is an absolute masterclass on the architecture of the human mind. We're going to be exploring how human intelligence actually develops from day one, and, more importantly, we'll look at the fascinating reasons why those early childhood milestones directly dictate modern college success. Seriously, if you've ever wondered how your brain went from, being easily tricked by simple illusions to suddenly solving complex, college-level abstractions, you are absolutely in the right place.
Okay, let's dive into this. Here's a quick map of our journey today. We're covering the growing human mind, major developmental theories, the nature-nurture dance, sudden shifts versus steady growth, and finally, transforming modern education.
So, kicking things off with Section 1, the growing human mind. To really get a grasp on our intellect, we've got to look back at the fundamental processes of cognitive development, and, well, just how incredibly fragile our early cognitive perception truly is. Picture this. It's 1969. And researcher Rita DeVries brings this incredibly gentle cat named Maynard into a psychology lab. That's step 1. For step 2, they literally place a realistic, terrifying mask of a fierce dog right onto Maynard's head. Step 3, children under the age of 3 burst into genuine tears. I mean, they were entirely convinced that this sweet cat had magically, physically transformed into a vicious hound. It's such a striking emotional reaction. And it brilliantly illustrates how a young child struggles to distinguish appearance from reality. It proves that early intellect isn't just a smaller version of adult intellect. It's a completely different, fragile journey, full of wonder and, frankly, profound confusion.
Now, you might be wondering, why does Maynard the cat matter to us today? Well, because those early foundational milestones have massive ripple effects. Just look at a March 2026 academic report. It shows that first-year college students are deeply struggling with complex problem solving. And the root cause? Advisors pinpointed pandemic-related childhood development disruptions. Because their foundational cognitive steps were interrupted years ago, both traditional teenagers and older non-traditional learners are now facing severe anxiety when trying to navigate abstract college course structures. It turns out, reaching higher-order reasoning requires a rock-solid foundation.
Let's pause and think about that connection for a second. In what ways do your current study habits reflect your own family values and early childhood goals? It's wild to consider, but how much of your current academic approach was actually cemented years, maybe decades, before you ever set foot on a college campus?
That brings us to Section 2, major developmental theories. How exactly do we explain this mysterious growth of human reasoning? Well, throughout the mid-20th century, there were some truly dramatic intellectual battles between psychology heavyweights, all trying to map this exact process out. One of the absolute biggest heavyweights in this space was Jean Piaget. He famously tested cognitive development by designing what he called conservation problems. Just imagine Piaget standing in his own kitchen, pouring identical amounts of water into completely different shaped glasses, just to watch his own young children get entirely fooled by the visual heights of the water. They completely failed to realize the actual quantity was exactly the same. Piaget used tasks like this to prove that while children do actively construct knowledge, their logic is fundamentally constrained by their developmental stage. When we compare these major frameworks side by side, you can see three completely distinct perspectives trying to explain human reasoning. First up, you've got Piaget's structuralist approach, arguing for 4 invariant stages of maturity. Qualitative shifts, basically. Second is the information processing theory, which essentially views the human mind like a digital computer, focusing heavily on mental constraints like memory and attention. And third, Vygotsky's sociocultural framework, which completely broke the mold by arguing that development doesn't happen in a vacuum. It is deeply embedded in social contexts, cultural tools, and interaction.
Now, what's really interesting about this slide is how these decades-old theories are actively saving modern higher education today. By June 2026, researchers found that when universities actually incorporated Vygotsky's principles using collaborative digital forums, graduation rates for non-traditional online students significantly improved. Choosing the right developmental theory isn't just some abstract academic exercise, it literally dictates whether a student drops out or graduates. It perfectly encapsulates what Vygotsky meant when he said, "Through others, we become ourselves." Social interaction isn't just a byproduct of learning, right? It is the true engine of our internal mental architecture. Moving right along to Section 3, the nature-nurture dance. This is the age-old debate of biology versus environment. We so often try to split them into neat, separate categories, but as we'll see, doing that is pretty much impossible.
let's look at a rather somber, frankly heartbreaking reality from a 1995 observational study by Judith Langlois. The data revealed that parents naturally provided more affectionate care to easygoing, visually appealing babies than they did to difficult ones. I mean, wow, this is profound because it shows that a child's inherent genetic traits, their biological nature, actively alter the social care and everyday nurturing environment they receive. It's a constant, inescapable loop.
So on one side, nature acts as the raw biological blueprint for brain structure and genetic inheritance. On the other side, nurture represents our everyday environmental, social, and cultural experiences. But they are inextricably linked. Genes provide the structure, sure, but everyday experiences dictate how those specific neural connections mature over time. You simply cannot have one without the other.
And we see this interactive dance paying off right now. In April 2026, findings from community colleges show that student success relies entirely on combining natural talent with tailored environmental resources. Non-traditional students balancing full-time jobs are showing incredibly high cognitive adaptability. But, and this is key, they only unlock that biological potential when the environment provides supportive peer networks and modern study labs. The environment literally unlocks the biology.
The great psychologist Donald Hebb anchored this entire debate beautifully when he stated, "Nature grants the canvas, but nurture paints the masterpiece of the human mind. Our intelligence is an ongoing, lifelong collaborative artwork." Let's transition over to Section 4, Sudden Shifts versus Steady Growth. Here, we're exploring a major structural question. Does our intellectual maturity happen in abrupt bursts, or is it through a slow, smooth accumulation?
Let's define continuous development first. This is the perspective that human development is a gradual, incremental, and quantitative accumulation of skills rather than a series of abrupt changes. Think back to that information processing model we touched on earlier. It views our minds like computers that are slowly, steadily upgrading their processing speed and memory capacity over time.
So the crucial point is, are we looking at discontinuous development, meaning rapid qualitative shifts and abrupt stage transitions, kind of like Piaget's stages, or is it continuous quantitative expansion and steady skill accumulation? Well, modern researchers actually utilize both, because as it turns out, different aspects of cognition manifest in completely different ways. A huge breakthrough here was Robert Siegler's overlapping waves model in 1997. It caused a massive paradigm shift. When he tracked children solving math equations over time, he didn't see abrupt jumps from one logical stage to the next. Actually, scratch that. It wasn't a jump at all. His data revealed a fluid sea of multiple, changing strategies. He proved that children don't just jump logical stages, but they simultaneously use multiple, beautifully complex ways of thinking. Development is incredibly unpredictable and fluid. And this historical pacing debate has massive implications today. In January 2026, academic journals explored how first-year college students adapt to expectations. They found that non-traditional adult learners feel completely overwhelmed by sudden discontinuous shifts in academic demands. Meanwhile, traditional younger students tend to show a more continuous, gradual adjustment period. Recognizing these pacing differences is absolutely crucial for colleges trying to design better introductory programs. Which brings us to our fifth and final, really powerful section, transforming modern education. How do we take decades of childhood laboratory theory and directly transform modern classrooms to rescue students from systemic academic failure?
Consider this super inspiring 2008 intervention by Siegler and Ramani. Step 1, they targeted lower-income preschoolers. Step 2, they introduced a simple numerical board game, very similar to Chutes and Ladders. Step 3, simply by playing the game, the children gained vital spatial and mathematical insights. And step 4, after just a few hours of this playful intervention, socioeconomic math achievement gaps were completely erased, literally erased. Basic laboratory research directly translated to saving children from systemic failure. Incredible, right?
And let's move to and see how this builds into February 2026. Regional universities are actively redesigning remedial math using interactive, gamified learning tools, exactly like that childhood cognitive strategy. By moving away from rote memorization and aligning with how our developing brains actually work, they are drastically reducing failure rates among diverse student populations. So, I'll leave you with this final, provocative thought. As the old saying goes, the mind is not a vessel to be blindly filled, but a fire to be kindled. How would your grades, your engagement, and your overall success improve if college courses actually match the fundamental way you think?
Thanks so much for joining me on this explainer, and keep exploring.